This is my solution to problem 4 of the LeetCode challenges called median of two sorted arrays. The problem states, given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be the order of log m plus n. Now I wasn't successful in doing this. My runtime is more the order of m plus n, and which is a little bit worse than log m plus n, because I used a bit of a more direct approach. So the way my method works is we know nums1 and nums2 are in order, they're already sorted. So I created nums3, which is another list, which has every single element from nums1 and nums2, but also sorted. Now, to begin my solution, so I'll start with the function, which is find median sorted arrays. The first thing I did was find the length of both of these lists, which the function is given. So we'll call them len1 and len2. So we find the len of both of these lists. And then I'm going to initialize two variables, j and k, which I'll make 0 for now, and we'll use them in a second. Now what I'm going to do is I'm going to initialize nums3, and this will be an empty list for now. And then what I'm going to do is I'm going to do some checks before we begin, because the length of these lists can be 0. So I do want to check that if they are 0, well, if they're both 0, what I want to do is I want to keep nums3 equal to this. Or what else I could do is I could just return nums3 as it is, if both of them are 0. Now, if, elif, let's say only one of them is 0, so len1 is equal to 0, then I want to return nums2. So I will just return nums2. And then elif len2 is equal to 0. So the second list has no elements. I'm going to just return the first list. So return nums1. Otherwise, we'll continue with the code. So to begin the code, I'm going to loop through every single element in both lists. So what I'll do is I will loop through the length. I'll loop through the length of len1 plus len2. Loop through that range because that's how many elements there are. And then inside this loop, we have an if statement. So I'm going to check firstly if j is equal to len1. And this won't actually be the case in the first loop, but because we're looping multiple times, eventually there might be a case where j is equal to len1, because we're going to iterate j at certain stages. So if j is equal to len1, so j, what I meant by j and k, j represents the index of the element in nums1 that we're up to. K represents the index of the element at nums2 that we're up to. So if j is now equal to the length of the first list, that means we've reached the end of it. So we can now just start appending the last elements in nums2. So what we'll do is we'll append to nums3 the final elements in nums2, which will have index k. And then what we'll do is we'll start to iterate k by 1. Then what we'll do is we'll do another elif statement. We'll check if k is equal to len2. And this is just the opposite of what we've just done above. So if k is equal to len2, it means we've reached the very end of nums2. So to nums3, we append nums1, the jth element of nums1. Then we iterate nums1 by, j by 1. Now let's do another elif statement. So in this elif statement, we will check. So we've done our two initial checks to see if we've reached the end. So if j and k have reached len1 or len2. Now what we can do is we'll run another elif statement, which will check if the current element we're up to in nums1 is less than or equal to the element we're up to in nums2. If this is the case, what this means is, it means we're looking at an element in nums1, which is less than nums2. So in our final list, nums3, it should appear, or we should append it before we append nums2. So what we're going to append to nums3 is we're going to append nums1j, and then again, we'll iterate j in this case. Then we can just put an else statement, and the last thing that we haven't accounted for is when nums2 is less than nums1. If that's the case, we need to append nums2 and then iterate k. So again, to nums3, we will append nums2 at the kth element. Sorry, this should be nums3. And then we will iterate k by 1. There we go. So we're almost done. Now what we'll do is I'm going to find the length So the length of nums3. And this is because, well, I'm going to do a check. So I'm going to check if the length is either odd or even. I'm going to use a modulo operator. So I'm going to do if len3 is odd. So if len3 mod 2 returns 1, then we will have a true statement. So this is if true, which occurs when len3 is odd. So if this is true, or if len3 is odd, our result should be nums3. We're going to do the very middle of nums3. We're going to index into the very center of this. Because if we have, say, 3 elements in our list, then the length of the list will be 3. When we do the integer division of 3 by 2, we get 1. Indexing into the first element is the middle element, because we have 0th element in the Python language. Now, otherwise, what this means is we have an even amount of elements. So we need to take the sum of the 2 innermost elements, or the centermost elements, and divide that by 2. So the 2 centermost elements, when we have an even number of elements, we're going to index in to, again, the length of nums3 integer division by 2. And then we're going to add to this. We're going to index into the same one, but we're going to iterate it by 1. So what I mean by that is we're going to take the length of nums3, integer division by 2. Sorry, minus 1 over here, not plus 1. And these should be nums3. So again, let's think about it. If we have a list which is 4 elements long, when we take the integer division of this, it is 2. The second element is the third element technically in the list, which isn't the exact middle one, it's a bit to the right. So that's why we minus 1 over here to get the one a bit to the left, and those are our 2 innermost elements. Once we have this, we can divide the entire thing by 2, and this will give us our answer. And what we'll do just as a sanity check is we will print the result just to confirm that we have figured out what it is. And then at the end, so the function wants us to return our final answer. So we can just return a result. I've just printed this out just so we can check it ourselves. So I'm going to run the Python file in the terminal, and let's see what we get. So we get 2.5. If we scroll up, we can see our 2 lists are 1, 3, and 2, 4. So once we sort these all together, we should get 1, 2, 3, 4. The 2 median elements are 2 and 3. So we have to take the sum of those 2, which is 2.5. Let's get rid of this 4. We should get 2 now as an answer. So when I run the Python file in the terminal, we do get 2. And then let's try another number. So let's try 0 over here and run this Python file in the terminal. We should get 1, which is exactly what we get. So just to wrap up this, the video, I did see a video solution online for this one. It's a very elegant solution. It's definitely much better than mine. They use a binary search algorithm where they use kind of similar to a sliding window solution. It's something that I didn't fully understand myself, but I do want to challenge myself to reattempt in the future to see if I can get it similar to the way the video did. It's definitely much better than mine, but for now, this was my first attempt at this question. So for problem 4, this is my solution.